Hi, I'm Tanawat UNSIWILAI. Today I'm going to show you the industrial robot simulation in the Robot Studio application. So this is the simulation of 6A6 robot arm in the real application in the world. It's like a pick and paste the object and or call the workpiece from the first conveyor to the other conveyor. So it's moved until found the sensor and then it stopped by the first arm. It's gonna pick up the workpiece from this conveyor to the other conveyor, and the second robot is gonna grab the workpiece that sent from the first robot, and then it's moved to the workstation to send the workpiece to the next process of work. So I used two robot model for this application. So this is the popular robot. It's used almost it's always used in the real situation in the industrial. It's always use this two type of robot. So first is IRB 1205 and 90, and the second is IRB 14105 144. So first, this is a specification of IRB 1410. So first thing is have a 6 degree of freedom, and you can see on the my cursor, this is a working range, or you can call it like a stroke. Uh, so the max velocity is 2.10 meter per second, and the supply voltage is 200 to the 600 volts. Rate power is 5 kilowatt. So the maximum payload, this is a very important thing that you have to consider it before you apply it to the application. So the maximum payload is a 5 kilogram, and stoke is like a maximum of working range. It's like 933 millimeter. All right, and then the second robot is a IRB 1200. It's a 6 degree of freedom too, and it had a maximum payload 5 kilogram too, and the working stoke is like 900 millimeter. You can see this on the working range. All right, and then I came back to the program, and I used the vacuum gripper to be a gripper. So vacuum gripper is a tool, is an effector of the robot. It's a effective tool to grab a thing. Is instead of we grab by a gripper or hand, we can use the vacuum to, it's like a pneumatic system to whoop, to vacuum the thing. It's easy to change, it's easy to use, it's easy to apply it on an effector of robot. We use in the term of robot. So next thing, the workpiece size. I used I used the 100 millimeter by 100 meter and by 100 meter with range high Okay, and then workspace is like a 3 meter, 3 meter. From this to this and from this to this is called working space. It's like a 3 meter by 3 meter with and range. And then the distance between the robot have to grab work. It's like a 1 meter from first conveyor to the other conveyor. The dimension is 1 meter. And the stroke of robot is like a maximum of robot can uh, stroke the work. It's like a 900 millimeter. So next thing is we can move to the coordinate system. The coordinate system, I use the wait a minute. The coordinate system I use from this to this. The first robot, I use coordinate system to setting up the position of working space that the workpiece is moved from conveyor, if moved on the conveyor to the position that I set up, and then the coordinate from the robot is gonna move from this to this. You can see on this on the coordinate system that I set up on the first robot to gonna grab the work, and then from the other robot coordinate system is is the same too. Okay, and then how to calibrate them, calibration of these two robots. We can use the path. We can set up the path and the target. We can create the target, and we can create a path to teach or give them an instruction by this, or you can use the teach pendant to jogging and then set the position and then give me a code, and I will explain you about the teach pendant to coding the next step. But first of all, we can use this to the I'll show you the uh, path and the target. First target, we can set the coordinate system like this, and then we create a target and then when we have a target like move j home, and then we can add up to the main part, and then we can create a part. So first of all, move j home is like a move the first robot to the position that we set home, and then we set do we pick up we pick up the workpiece that I set up on the coordinate system like this, and then we move when we pick up we move it to the other conveyor, and then next process is to move the second robot like this. You can see it easier when I show you. I'm gonna show you the simulation of this work later when I finish to explain it, and then I'm gonna discuss about the code. The first code is on the station logic. The station logic is like a code that we can picking up the label. We can create a label. We can use the symbolic interest of coding, but it had a code on the label, but it is easier to use. First is like a feed in. I'm gonna show you on the feed in, on the input feed in. Feed in it, I use is like a the platform to send the data from the robot to the other robot. It's like a, you can see it has an input output signal because it's like a platform to send the data pass through. Okay, first of all, I use the part ready and pickcom, part ready and pickcom as my work. It's like a pick and place the robot. It's like a robot pick from the conveyor to the other conveyor, and then I link up to the RB robot. It's like a first robot. I link it up, and then X pose is a X position and Y position and Z position of the workpiece. Yeah, I will show you, and you can see it easier when I click on simulate. You can see the, like me. You can see on my cursor when the robot move, it show on the position of robot on this. Yes, and it's gonna link up to the other robot. You can look up like a sensor and feed out too. Feed out is like a feed in, but it's like output. It's like output feed out, and you can see is have a lot of output terms. Vacuum is like an output, and sensor we can link up it to the another robot, and it have the same logic of coding too. All right, its annual palette is like a attach the attach is like a the end of work, and we have to set it up clear. All right, you can see the detail from this, and then I'm gonna discuss about the code on the teach pendant. Like uh, by this technique you can use just only the create the target and create a path and simulation to create this simulation, but you can use teach pendant instead, because of this teach pendant is like the tool, the controller is had more flexible to use. It's like a joystick to control the robot, and we can set it up, we can program it, we can give it the data that we gonna move them. So I open the teach pendant, and I'm gonna show you how to jog it. First of all, you have to start on the motor